Good morning. We are the second part of the automatic cheese or roll production machine. This is Carlos Mazquiaran, Omar, Vichot, and myself, Stephen Marquez. Next slide, please. As the previous group already mentioned, we are in charge of automation of the production of a very popular product produced by a company named SDO. It is a wholesale bakery which provides to big name companies such as Whole Foods, Walmart. They supply frozen baked goods for baking in smaller bakeries. Excuse me. Our goal is to increase demand from 11,000 per week as they are producing now, increase production, my apologies, from 11,000 per week as they're producing now to 11,000 per day. The product is a cheese stick, and they call it palito de queso on their brochures. This, as you guys may know, is a collaboration between two groups. We have, since it's such a big project, we had to split it up. There's the stage 2 system, our system, what it is in charge of. We have to dampen the dough for better cheese adhesion. We have to then press the dough down with a roller, and after which we have to roll it in such a way that it mimics hand rolling. It is very important that this is part of this product because it is an artisanal touch, and it's one of the main draws to their product. Here is a video for a better idea of what we have to accomplish with our machine. Here he is wetting the dough for the cheese adhesion. And this process, Omar will speak about it later, we are thinking about a sifter, more or less like they have done here. The next one will be taken care of. And this is the very tricky part. Getting cheese on both sides and getting it to look like it is textured by human hands. And here are the sheets that we have to deliver it onto.
Could you go back? Sorry. Show that one more time. I appreciate it. So currently we have three conceptual design, and we're basically trying to focus more on how we're gonna fold the cheese stick. So basically what we have is two sifters. The first one's gonna go before the dough actually falls onto the conveyor belt, because the cheese stick has to have cheese on both sides. And then there we're gonna include a water spraying system, because we need water so the cheese can stick to the dough. Once that the dough falls, the sifter again throws cheese on the dough. Once that, we just try to flatten it a bit so the cheese sticks on both sides. Pass it through a mesh so it could get the initial twist, and then two rollers. We're probably gonna try to increase it more to mimic the hand twisting motion. For the first one, what we're planning to do is offsetting the machine with stages 1 machine by 45 degrees to get an initial twist of 45. And we were thinking about stainless steel rollers. For the second design, we're not going to offset the machine. It's going to be the same with stages 1 machine. But instead of using stainless steel rollers, we're planning on possibly PTF sleeves with stainless sanders. Reason is we don't want to increase cost by using powder to prevent sticking. And then for the last design, we're gonna do like the same like the first design, offset 45 degrees, but instead of that, use PTFE rollers. For the design specification, for the final design that we're gonna give the company, We're gonna be using 304, 306, and 316, sorry, and 430 stainless steel. Reason is, it has to do with the FDA Food Code 2013. It has to be a material that's corrosion resistant, easily cleaned, and the reason for this is to prevent bacteria buildup. For the conveyor belt, we're thinking about using a thermoplastic elastomer. Again, this has to do with FDA standard 21 CFR 175.300. Reason for it, again, bacteria prevention, easy cleanup. Now for other, we want the machine to be modular, so it's easily repaired, easily disassembled in case if something goes bad. For the rollers, like mentioned before with the 3 designs, we're going to either be going with PTFE solid completely, stainless steel, or stainless steel core with PTFE coating. This has to do basically to see if we can reduce the cost of throwing powder to prevent any stick with the rollers. And then we're going to be using a cheese spreader. Most likely we're going to be using a vibratory sifter to disperse the cheese at the beginning and the middle of the process. Instead of a dispersion cylinder, which we were thinking about, it was going to scoop up cheese that's already grated and press onto the dough. Cheese stick rolling process will be, again, using a stainless steel mesh. This has to do, again, with the FDA standard code 2013. And possibly a water application system to filter water. We will most likely be using tap water, but again, to prevent any bacterial buildup or any contamination with the food. And we're going to be using sprayer jets to spray the water onto the dough. For standards, we're going to be using FDA's approved materials. And for OSHA safety standards, we're going to be using it's 1910.263, which has to do with bakery equipment. And that basically is if we have any belts that are going to be exposed, we have to cover them. Since if they're within 8 feet and 6 inches from the floor, they have to be covered so there's no incident of finger staining kind with gears, belts, and so on. And for local design consideration, the reason why we're using a water filtration system is if the company decides to take this machine to any other country, we know here in the United States, water is usually clean and it's already good for human consumption. For example, if the machine's taken to South America, tap water might not be as clean as here, so we just want to prevent any bacteria-related diseases or contamination with food. Dimension tolerances, as mentioned by the first group, it's going to be in English and SI units. And product manuals will be included in several languages so the user of the machinery knows how to operate the machine.
I'm going to speak about our schedule. We start in January, we are right now at the end of April. So we start like the topping selections during February. We did research, we started the design then. We are right now like at 25% of our project. So all summer we're going to start working in the design, in the final design of what we're going to do. We're going to do the SolidWorks, we're going to do the simulations, we're going to do the testing if we can, and start assembling the machine. The responsibilities of each team, of each member of the team. We're going to divide the project in 3 main parts: the reports, the designs, and the product. We are going to work all together, but some of us has main responsibilities, so due to their strength. So, for example, in the writing, we are all going to do the writings of the proofreading. For the formatting, I'm going to be in charge. The designs, we're going to divide in calculations, drawings, simulations, personalities. Basically, we're all going to work in this together. And for the last part of the project, we're going to do the manufacturing, testing, optimization, and final design. This is our poster, as you can see it over there. And this is what we're looking for. This is going to be our final product that the machine is going to do. Thank you very much for your time. That will be all. Do you have any questions?
Yeah, of course I do. Yeah, the first question, and the reason I asked you to go back over the video, is that there is some art to the rolling. It's not just rolling, there's stretching event going on here to get that nice event. Have you taken that into account in your rolling design?
Yes, we have. If you could go back to conceptual design too. As you can see, the rollers aren't really cylinders. The reason for it being dynamic, for example, your fingers, when you roll something, you're putting more pressure on one part than the other. So that's what we're trying to mimic here. We're going to try to put it closer so it could, when it's rolling, it kind of stretches outward. But we're most likely going to use more than 2 rollers. Again, this is just an initial design that we're planning. By employing more, we're going to try to mimic the 3 times before the employee did.
But remember, they're doing this.
Right.
They've got some outward force.
Right, but again, when it's going from one roller to the next, it's already being stretched and it's already going, once it finishes with the first roller, it's going to go to the next one already stretched and the third one already stretched and so on.
We're relying on the curvature being random on these rollers to apply some stretch on this curve, and then the next one will not quite land on the same one, so it'll stretch a little more. At the end product, it will stretch.
Okay, and you've designed it so that there's enough width to this system so that your initial material won't be falling out?
Yes,
Yeah.
yes.
Stretch
We've
like-
taken measurements, and the finished cheese roll as done by hand is about 7 1/4 inches long.
Okay.
We've made our machine 24 inches to be able to do 2 up or 3 up. Not 3 up, I apologize, 2 up.
Okay. Next question area is on the water application. Because you talk about spray jets.
Yes.
Isn't it more like a mister? More like creating a very fine mist that gets you good, just
No.
enough water, not too much?
Correct.
Not too fine, as you may find in Islands of Adventure, the misters in front of the fans. Not that fine, it's a little more droplets. So if you imagine
But too much
pesticide
water is
spray.
not good. I
Oh,
saw.
no. That will go into the design by the size of the orifice and how much volume we're pumping into these jets.
Okay, and then the last question area is obviously cleanliness issue and the ability to tear this down and clean it and put it back together and still get it to run the same way as it did the first time you built it.
How we're going to approach that?
Yes.
Good question. So every one of these is going to be sealed. So we're going to use sealed bearings, nothing that may be able to contact the food. All of these rollers are going to be on quick release systems that are just flip it over, pull it out. Something very easy, that very outside, so that no rear tear down, no downtime is put into maintenance, no lengthy downtime.
And then safety, you clearly have to
Yes.
protect yourself on pinch points and design with lockout, tagout approaches on systems like this.
Of course.
So you
So
can't
that
have an
the machine
electrical
doesn't
hazard.
start.
Can't start the machine. Someone can't be in the machine and somebody accidentally turn on the machine.
We didn't mention it here, but all of our motors, pulleys, drives, anything that can be a potential pinch point will all be put on a shelf down here. Sorry that it's not clearly put on here. All of the sides will be encased as well. The only thing accessible to the operators will be the main control panel that will be designed in such a way to incorporate lockout tabs. And of course the maintenance, whatever they need to take apart, disassemble it.
Thank you.
I guess you guys have already, you're going to a third of the way of the project itself. You still have time. Quick question would be is, have you guys considered benchmarking at this level? You're already into a level of this, of the conceptual design and the actual work of the design. It would be very good for the sake of the machine garden, which the gentleman just spoke about, the sanitizing of it, the modularity of the equipment. If we were to look at real-time equipment that's being used in industry, not necessarily for other things, thing comes to mind is Minneapolis, Pillsbury, the Rolls, right? If I were to call them up, I would take a flight over there, pay $200-300, go over there for a day, do an industrial tour of their area. It's a major, major company that does these industrial rolls. They play with dough every day, they do all of this. I wonder if something can be learned from that, to integrate it directly from benchmarking directly into the machine, so that you actually capture these things that we're always talking about, the sanitization issue of foodborne illness issue, the machine guarding, the actual roller of the mechanizing of injecting this cheese all the way through, rolling it together with the cheese and process the outside of it. Things that you will capture on, because videos on YouTube is usually very limited, right? You don't get to learn too much unless you're right there with an operator, asking them, how do you do this? How do you not do that? For at least a half an hour to sit down with an operator that does, Pillsbury dough for the entire day, you probably get a lot of stuff. So can you comment on that? Have you kind of dwelled on that or asked
Well,
somebody?
I'm going to step in here on this one. You just did something that's absolutely a no-go, industrial espionage. You
No.
don't do that. If you're going to go see a company, you've got to get an NDA, a non-disclosure agreement, and you've got to have an agreement between yourself and that company that whatever you see belongs to them. You do not walk into
No.
anybody and look at their facility and then go out and design a machine.
No,
That's a complete no-go. You can't do that.
Yeah, I'm not talking
That's
about.
an ethics issue.
Yeah.
You can't do that.
There
And
is
if
a-
you start doing those type things, you can end up in a very, very serious space. Designing independent, perfectly fine. Walking into somebody's facility like that and then taking that information even into your inference of design, even if you get inference, you can get sued for that in the future. Absolute no-go.
Well, I'm not talking about stealing designs, I'm talking about benchmarking, which is.
You don't
normal
benchmark
practice.
in someone's facility.
Well,
If it's public record,
there is a process for
You can do that.
benchmarking, which they have to understand how it goes, and the communication has to start with the company that they would like to benchmark. Obviously, the NDAs and all of this information is already there. I know because I do benchmarking as well. And we don't come into any of these issues because it's not necessarily the IP that you're looking for. It's processes and things that are not necessarily proprietary for them. We're talking about materials that are being used, certain handling methods, putting on a glove and making sure machine guarding is used is something that is industrially wide used for other
Well, there's
machines
public
and other
standards for
equipment. So these issues obviously are within play. I mean, they have to understand what it is. So it's not stealing designs or anything like that. Can we comment on that?
Okay. First of all, thank you for your input, sir, and thank you for your question. We, as a team, are very lucky to be able to work with a company that is already established and already has food processing machines in place, and how they want their process made. We got the chance to speak to several operators, and Mr. Saperstein, who is here, and he walked us through the production plant and had us see how they go about transporting the dough, how they go about handling the dough, and from there we've drawn ideas on what you have said, what materials to use, how to keep it clean, how to minimize foodborne illnesses, along with the FDA standards that we have looked up and work on.
I have a question, and it's during the process we spoke about the size of the machine, which is really important too. We don't want to create a monster, and we want to create something that's going to fit in our space. Not to say that we're going to keep the space the way it is. Obviously, there's room for improvements, but what will be the final length of the machine, starting with project number 1 to the end of yours?
What we spoke about in our meeting is that we were going to design, if we do decide to offset our machine 45 degrees, we will end up with a 10-foot long machine, which will give us 7 feet to this side and 7 feet to this side, roughly. Excuse me. We are trying to stick very closely to that, since these are the figures that we did give to you, we did present to you. And we spoke about Team 1's design as well, that they are very vertical and they're very compact. So space impact, we are trying to minimize it as much as possible. And as well as, you mentioned you wanted 2 operators. to operate this machine.
Ideally,
Ideally,
yes.
of course. If you've ever heard the expression, I'm sorry if I'm being unprofessional, too many cooks in the kitchen, we do not want operators bumping into each other, so we are definitely trying to minimize space and still come up with all these processes. Eventually, but finally, experimentation is going to dictate much of how much space we need between one process to the other to not create, say, a bunch up between the rollers or unforeseen design complications.
So for the stainless steel, you picked 304, 316, and 430. Why so many types?
Well, 304 and 316s, they're the same thing as in corrosion resistance. Since we're still in the initial design, we're most likely going to go with the one that's going to be cheaper in terms of rollers. If we're now use Teflon coating, we're still going to keep it so it won't corrode because it's going to be near food contact. 430 steel, we're not probably using in case for example, for the legs of the structure, since there's not going to be any food contact. It's still going to be corrosion resistance, but it's more likely to rust or pit compared to 304 and 316 stainless steel. That's the reason why we have right now 3 different stainless steels that we're planning on using.
To add to that, 316 is more corrosion resistant, and that will be used in more acidic environments where it will hold up better than 304. 304 would be more for dough and things that won't cause so much of a corrosion issue. 430, as he mentioned, will be like covers and things that are not direct food contact and sufficient spacing away so that
When picking your stainless steel, you also have to remember machinery. How are you going to be able to machine it properly? Some metals are softer than others, and of course corrosion is important. But for certain applications, some of them might be easier to cut into than others.
Of course. 316 and 304 are free machining. 430, since we are doing it in sheets,